In this video, we're going to take a look at how we can use our knowledge of linear functions to model real-world situations and to answer different questions or find missing information in those real-world situations. So, first we're going to start with some basic problems and then we'll work our way up to items that are a bit more complex. So first we have Matt, who owns a plumbing service, and he charges a flat rate of $50 and an additional $30 per hour after that. So the first thing that we want to do is figure out what our two variables are. When we're looking at Matt's plumbing service, we have cost and number of hours. And the cost depends on the number of hours. The number of hours is going to be our x, or our independent variable, and our cost is going to be our y, or our dependent variable. Now, depending on how you want to do this, you could say that c is going to represent cost and h is going to represent hours, or we could do y and x for those. It doesn't matter. You just want to make sure that you always start by defining your variables. So now we want to figure out what our equation is going to look like. So we know we're going to be figuring out what our cost is, and that's going to be equal to our flat rate of $50, which when we talk about flat rate, this means it's like a one-time thing. We're only going to pay it once. So basically he charges you $50 to come to your house, and then an additional $30 per hour after that. Anywhere we see the word per, that's a good hint that we're going to have some multiplication there as well. Pause the video, see if you can figure out the equation for the scenario below. So for this one, again, we come down to cost and our amount of extra data that we use. So our cost is going to be equal to our $40 monthly charge plus $15 for every additional gigabyte that we use. So if we define G as our additional gigabytes used, our equation would look like this. Now, if we just want G to be gigabytes used, then our equation is going to look a little different. So our cost would be still start with our $40 fee plus 15 times G minus 2. Since we're taking away the 2 that we get, we don't want to be charged that extra 15 unless we use more than 2 gigabytes. So either one of those will work. Alright, so here's where things get a little more interesting. Go ahead, pause the video, read the problem, and see if you can come up with anything important that we need to pull out of there to use. Alright, so looking over this, we have the amount spent on advertising and number of pairs of shoes sold. The manager of Foot Locker has control on what he spends on advertising. So the amount spent on advertising is going to be our independent variable here. He has no control over who comes in to buy shoes. So if we put S for the number of shoes, that's going to be our dependent variable, or our Y here. Okay. So we have two numbers that go together. We have $500 and 270 pairs of shoes, and we have $1,250 and 510 pairs of shoes. These are two ordered pairs. So we have $500, 270, and we have $1,250 and 510. The first part of our question is asking the average amount of money that the manager spends on advertising per shoe sale. So when we talk about average, this is where our rate of change comes in. And remember that rate of change is the same thing as slope. So I have two ordered pairs here, and we're going to use that to find the slope. So we can do 510 minus 270 all over 1250 minus 500. And then we just go ahead and simplify this expression to get our slope. So we end up with 240 all over 750. And when we do that division, usually when we're dealing with the word problems, we're going to want to get decimals because we want to know exactly what these values are. So here, we end up with a rate of change of 0.32, which means that he is actually only spending about 32 cents per shoe sale. Okay, and that's going to be our slope in our equation. So now we want to go ahead and write the linear equation in slope-intercept form. So this is where we want to be careful to make sure that we know what form we're being asked to write in, because we make sure we do it correctly. So we have two ordered pairs, we have our slope, so we know that y is going to be equal to 0.32x plus some y-intercept, and I can use any of my 2 points to solve this out. So we have 270 equals 0.32 times 500 plus b, and now I just go ahead and solve both sides and to figure out what b is going to be. So we have 270 equals 160 plus b, which gives me a b value of 110. So my equation is going to be y equals 0.32x plus, not plus b, plus 110. The last part that we're asked here is that if the shoe store sold 1,510 pairs of shoes, we know that that's a y value, how much money did they spend on advertisements? So what is x equal to? Go ahead, pause the video, and see if you can answer this question. So again, we know that 1,510 is a y coordinate, so we sub that in for y, and we're looking for x. We subtract 110 from both sides, divide by 0.32, and we get 4,375. Now with the word problems, we always want to make sure that we include a unit, so we want to tag that $sign in with our answer. Alright, next we are looking at movie theaters. So we have data about how that increased. So in 1996 there were 29,690 movie theaters, and we know that it increased by about 1,500 each year. So this is going to be our rate, or our slope, and this data is going to give us an ordered pair that we can use. 99% of the time that we have time as one of our quantities, it's going to be our independent variable, because time keeps going on even though our rate of change, or even though the number of movie theaters may not be changing. So here we're asked to find the average annual rate of change, and that's already given to us. So our slope here, well, that's not an m, our slope is going to be that 1,500. So part A is done. Now we want to write the equation in slope-intercept form. So far we have y equals 1,500x plus b, and this is where we're going to take that ordered pair and substitute everything in. So again, our year is going to be our independent variable, so we have 1,500 times 1996 plus b, and on the other side of the equal sign we have our 29,690. Go ahead, pause the video, and see if you can solve for the y-intercept and finalize your equation. Alright, so we have our slope of 1,500, we have our x and y coordinate, we substitute everything in, we end up with a y-intercept of negative 2,964,310. And remember, our x coordinates are all years here, so we're plugging in pretty big numbers, so our y-intercept is going to be a very large negative to offset those big values that we're plugging in. And the last thing we want to do is predict the number of AMC movie theaters in the US in 2005. And this is going to be an x coordinate. Pause the video, see if you can figure this value out. We go ahead and substitute 2005 in for x, simplify the right hand side, and we get an answer of 43,190 theaters. Again, making sure that we want to include that unit there. Alright, here's our last question. A parachuter can free fall if the plane goes high enough in altitude before the chute must deploy. Here we have a table of altitudes, or distance from the ground, and how many seconds the parachuter has been falling. Now here, the time since we've jumped out of the airplane is going to be our independent variable, and our distance from the ground is our dependent variable. In order to find our rate of change, or our slope, remember that we can use any 2 points. So if we just take the first two here, that's the point 10, 9,550, and the point 20, 8,100. So we can substitute that into our slope formula and solve. So we have 8,100 minus 9,550 all over 20 minus 10. So now we go ahead, we do our subtraction. We have negative 1,450 over 10, or negative 145 feet per second, which makes sense that our slope is negative because my distance from the ground is decreasing as time goes by. So this represents that with each second I get 145 feet closer to the ground. Next, we want to find the slope-intercept form of the equation. So we know that we have y equals negative 145x plus b. And now we can substitute in any one of our points from the table to solve for b. So if we use the first entry, we would have 9,000. Our pen switched off here. Hold on. We have 9,550 equals negative 145 times x plus b. We go ahead and solve here. We get a y-intercept of 11,000. So this means that when x is 0, y is 11,000, or in other words, at time 0, our height is 11,000. This means that the plane was at an altitude of 11,000 feet when we jumped out. So our final equation is going to be negative 145x plus 11,000. The last part that we want to do here is estimate the altitude of the jumper after 35 seconds. So this is an x-coordinate. Pause the video. See if. So here we get an altitude of 5,925 feet.